About the solid principles in programming, and this works for any programming language, but what I want to cover is what it really means in Swift. And to start off with, let's dive right in. Single responsibility, that's the S part. And what this really means is that one class will be calling helper classes that only do one thing. So for example, we start off with, we have this my class does everything, and yeah, it's built with many functions and it's supposed to be doing everything, but that's not the way we're supposed to be doing things. So it'll work, but that's just bad coding design. So let's not do that. We'll do this thing that does just one responsible area, and in order to accomplish that, it'll rely on other classes that also only do one thing. It doesn't have to be just one thing, but one area of responsibility is the key behind this. And that's what it's supposed to be doing, which looks a lot more nicer. So this is already a common theme that you'll see throughout the solid principles, is breaking things down to essential components and dividing the work and stuff like that. So keep that in mind. So the next one is open close. So this means that you don't want to go back to refactor your code. It should be adaptable so other things can use it. So we can have a class like myCloseThing, and it's dependent on another class, this thing. But what would happen? Well, let's try this out for now. And this is doing something. That's great. But what happens if you had thing 2 or 3 or 4? You'd have to go back and refactor myCloseThing and to make a new implementation for thing 2, 3, and 4. So instead of that, we're going to be using protocols, and we can make a generic thing with a protocol. So we can have a new thing implementing generic thing, and now we have our open close thing implementing that generic thing as well, and hopefully that will work. Here's a new thing, and you can have as many new thing 1, 2, 3 as long as they implement generic thing. They can fit in there, and that'd be wonderful. Moving on, we have list scope substitution, and substitution is basically a child can replace a parent, and we'll use protocols to solve that problem as well. Protocols is very important. We have, for example, we have a rectangle, and here are the characteristics of a rectangle, the area, but square is also a rectangle, so why not inherit rectangle there? So we have a child class inheriting the parent class rectangle, with one difference. The difference is that the height and width will all be the same. That's the characteristic of a square. This is kind of this should set off warning bells right away when you put in the value of the width, and the height changes as well. Well, let's get to it. If we have an outside source making an area calculator in order to take in the measurements, and it should be able to take in rectangle. But this also means it should be able to take in square as well. So let's see what happens if we create this. So let's put in our rectangle. And hopefully that works out. Yeah, 3, 5, that's exactly what we would expect. But we put in square now, and we're still putting in 3 and a 5. And no surprise here, this is something different. That's not what we expected. That's not how an area should be for a rectangle. There is no solution to this because a square is not a rectangle, and the solution is not to recognize it, that this child cannot substitute the rectangle. So don't code it that way. We should be using a protocol here again. So the common thing that they have in between them is area, and that's we can use a shape for that instead. So now the rectangle implements shape, and the square implements shape. But the rest is different. We have a side, and we have area is calculated in a different way. So now we instead we create our shape calculator. And that's basically all it cares about. We can take a shape, we can take any shape now. And so if we try to implement that, and we put in our rectangle first, So we initialized 3 and 5, and we got what we needed. Now we're not initializing 3 and 5, it's just a 3 because a square is a square is a square. And put that in there again. And then it behaves a little bit more expectedly without the preconceived notion that it's supposed to be a 3 and a 5. But now this can take in any shape, and that's much nicer coding. So we're moving on already from NISCOPs to interface segregation, and this means to make small protocols to implement extra stuff you don't to not implement extra stuff you don't use. So we don't want like fat classes and having too many features and the child class inheriting that, and it's only going to use 1 or 2 features of it. There's a key word in here, and it's interface and interface. An interface exists in Java. Swift does not have anything called interface, but we do have protocols, again. And protocol is essentially an interface. So back to the example is that a protocol transaction has 2 features. And that might sound nifty, grouping them all together, but if we then have a deposit and implement transaction, we don't need the withdrawal. We shouldn't be doing that at all. We should instead be having a protocol using a deposit and another protocol for withdrawal and another protocol for transfer, and each one should be implementing the one thing. And if it so happens that you have a process that you want to both deposit, withdrawal, and transfer, okay, but then you can implement and write down deposit and withdrawal, all of them up here instead of just having one transaction. And that was interface segregation. Now we're at the end. We're at dependency inversion. This is probably the most complicated and hard to grasp. But this is, well, I'll explain it easily because this is not so easy to understand, dependency inversion. But what it really means is that instead of using classes, you use protocol extensions to loosen dependencies between classes. Now, if you Google around for solid principle, you'll see the term abstraction used a lot. And I'll explain that during this example here. So we say we have a high-level class and we have a peasant that's supposed to do work for the high-level class. Well, this is using a low-level class. So now this high-level class is now dependent on this low-level class. So they have a connection between them in here. And you know, high-level classes don't feel like to have such close connections to low-level classes. So that's really not the way we should be doing it, even if it does indeed work. Because if you recognize this, you may remember from the other principles that now we're stuck on this. First of all, what happens to if you have another low level class that you want to use in here? Right. We shouldn't be doing that. Instead, the solution is a protocol here again. So we have a peasant protocol, and we have a new peasant. He's a low class 2 peasant, but he implements a peasant protocol. So we also implement the peasant protocol in the peasant instead of implementing the whole class. And hopefully, this was revealed too soon. I'll get back to that very soon. So hopefully this will work. Low level class 2, and then we have a peasant, and he's doing his boring work. But they're not connected anymore. The connection is through the peasant protocol. That's a little bit social distancing, so that the high level class is very happy about that. But as I was saying earlier, there's this keyword abstraction here, and we don't have extractions in Swift. In Java, there's something called the abstract class, but we do have extension. We have protocol extension. Now, the protocol extension is not what you would. The behavior actually changes with a protocol extension. So, as we know, a protocol is supposed to define the methods, but if we extend it like so, nothing will really change. This is not called. But what we can do is get rid of this now. Normally this would be complaining because it's no longer conforming to the peasant protocol. But we have extended it. So what is not conforming is down here already now. So suddenly it gets called. No problem, no issues. And that's an abstract class in Swift. So, yeah, I hope you had it properly understood this. As I said, many of these things is not necessarily protocol. It's not dependent on structure class. It's just whatever you build, break it down into its component pieces and try to follow these principles. That's all for this video. Thank you. Bye.